Welcome once again. In this section, we are looking at a system of equation. We are to find the right solution for the system of the equation. So let's take it for instance. In the first case, we have 2x plus s squared plus y equal to y. And let's assume that one of the unknown, let's say x, is plus or minus 1. So if x is plus or minus 1, then in this case we have this place being, let's say, plus or minus 2. Then we have this place being also y here being equal to just the y there, and we have plus or minus that being equal to y minus y, which is just being equal to 0, and this is impossible. So we are going to use a different approach to do this all together. We are going to use a different approach. So what we're going to do is that in the three equation, we are going to make each of the variable the subject over there. So in the first case, we have 2x plus s squared y here being equal to y, right? And let's make y the subject here. So we have 2x, let's group like term. So we have y here minus s squared minus y. So we factorize y out and we have 1 minus s squared, and therefore y here is just 2x being divided 1 minus x. Let's call this 1, right? Yeah, so let's do the rest. Now in the second case, we have 2y plus y squared z being equal to z. So we are making z the subject in this case. So let's group like terms. So we have z being equal to y squared minus z here. Then 2y will be equal to z, then 1 minus y squared here. So therefore z here should be equal to just a 2y here being divided over 1 minus y squared. So that will be, let's call this one 2. And let's do for the third part. Now in the third part, we have 2z here plus z squared, x here being equal to x. So we make x the subject, so it becomes z squared here x. So 2z here will just be x here minus just z squared. So x here will be 2z, right, being divided by 1 minus z squared for us. And let's call this 3 here. Now what we are going to do next is to solve for the values for the system of the equations. That's for each of the unknown variables. So what we are going to do is apply a trick over here. So it is natural to make a substitution, right? Natural to make a substitution, because if you look at the denominators, you realize that we have 1 minus s squared, 1 minus y squared, 1 minus z squared in each of the cases, and we can make a trick substitution over there. So that you realize that in trig, when you have tan, let's say tan 2a, then tan 2a is just 2 tan a being divided by 1 minus tan squared a. Now what does this mean? Now if you look at this value here, or in each of the cases, you realize that we have 2z minus 1 minus z squared, then we have 2x and the rest. So it's more equivalent to this, right? So in this case, we'll say that, let's start with x. So let's say x here. So if z equal to that, so in each of the cases, x, y, z should be equal to what? Tan a. So let's take the first variable. So let's say x here is equal to tan a, right? Now if x here is equal to tan a, so if that is the case, then let's define the range of values for tan a. So you realize that for the tan function, realize that tan shouldn't be just half pi half, then negative half here, right? So now let's write a formula for that. So we have pi, then half, right? So half, positive half and negative half, it will make the function here undefined. So we have let's say k and then n, right? So a will be equal to kn, so which means that k should be all values, but k shouldn't be equal to half and then negative half, right? So k shouldn't be equal to that half and then negative half. in this. So now the question is, why am I saying that? So when we have the tan graph, right, we have half over 2, and let's say we have half here, and let's say we have negative half over 2, and let's say we have negative half here. Now it goes this way, right, and the next one will just go it will just pass through the half here. But in the case where you are drawing, now this goes this way, sorry, it goes this way, so you can see that there will be they have a meeting. So let's say this is pi over 2, so this one also goes this way. Then realize that their meeting place will just be somewhere around passing through within that, right? So km, when defining the theta, we have kn, right, where k can be any values but not half and then negative half, because within this range it will make it undefined. And so if that is the case, then we can say that for tan a being equal to x, right? For tan a being equal to x, then we can say that from equation 1, right? From the first equation, we established that y here is equal to 2x here 1 minus x squared. So if that is the case, then we are having just y here being equal to 2. That will be now realize that this corresponds to tan a 1 minus tan a square, right? So which means that s is just that. So y in this case should just be tan 2a, right? So y here will just be tan 2a. Now if y here equal to tan 2a for the first part, now that's for the first part. Now in the second part, where we had z here being equal to 2y minus 1 over y squared. Now if this, so in this case z here is going to be 2 here, then we have tan 2a, because basically y equal to this, so 1 minus tan 2a by a squared. So in this case z would basically be tan 4a, right? It's going to be tan 4a. Now when we go to the next one, which is x, then s is so because x was giving us s here is equal to 2z over 1 minus z squared. So basically this is going to be 4 tan 4a, sorry, tan 4a, tan 8a. So it's just increasing by 2 in each of the cases, right? Now if there's a, then we said that x here for the last part, x is equal to tan 8a, right? Now what we're going to do is look for a, right? Now we also assume from the beginning that s equal to tan a. Now we have 8a and then a over here, so we have 8a minus a. But remember that we made an we said a equal to kn, right? So if that is the case, then we have kn, and therefore we are going to have 7a being equal to kn, and therefore a here is going to be kn being divided by 7. It's not kn, it's k pi, sorry, k pi, where k is what, any value but apart from positive and negative half, right? So if this is what we have, then therefore we can write the possible values for x, y, and z. So if you have x, y, and then z over here, which means that for x we are going to have tan, we have so for z we can, so remember x, we said s equal to tan a. So for tan a is just k pi over 7, so that will be for that. Now for y, we said that it is 2 tan 2a kn k pi over 7. Then for the z we have done, we said it's 4a, where a is k pi over 7. Yeah, so this is what we have for each of the variables in this case. So in this case we are saying that k should be values within -0, -3, -2, -1, 0, 1, 2, all the way to 3, 2, and then 3. Yeah, so these are the possible values for k. Thank you very much for joining me in this section, and I'll see you in another section.